مع أخينا من ماليزيا السيد قاسم بهالي. السيد قاسم هو رئيس مركز الخوارزمي للفلك في ماليزيا، وكما قلت ماليزيا مهتمة بالعلم الفلك الشرعي منذ فترة طويلة من الزمان، ولها قسم في كليات الشريعة بعنوان قسم الفلك الشرعي، وقدم هناك بعض الباحثين أطروحات للدكتوراه والماجستير حول التأريخ لعلم الفلك الشرعي في ماليزيا. فإخواننا هناك جزاهم الله خيرا من السباقين، وفيهم علم من كبار أعلامنا في الفلك محمد إلياس صاحب خط التاريخ القمري. نعطي الكلمة لأخينا قاسم. سوف أكون صارما في الوقت لتأخرنا ومعذرة مرة ثالثة، 20 دقيقة لكل متحدث، وسوف نترك المناقشات لانتهاء العروض الأربعة. سيد قاسم تفضل.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Alhamdulillah Rabbil Alamin. Thanks to Mr. Chairman to sponsor and the coordinating committee to give me this opportunity in the second Emirates Astronomical Conference. Regarding to the topics, because of the time constraints, I will focus on the second part of my presentation, that is astronomy in Al-Khwarizmi. So today I will share with you all the role of Al-Khwarizmi Astronomy Complex as a center for astronomy education. So this is the view of the Al-Khwarizmi Astronomy Center in Malacca, Malaysia. So I will show you the location of the center in Malacca. So you can see the map here. So I show the distance between Malacca and UAE. And the distance is 5,555 kilometers. This is very nice number. So now I show you where is the Malacca is. So this is Malaysia. Malaysia has 14 states, and Malacca is one of the states. And actually Malacca is a small state in Malaysia with populations about 770,000 people only. And Malacca is well known because this is between Sumatra in Indonesia and Malaysia. There is a Straits of Malacca, this is among the busiest straits in the world. So this is exactly the exact location. The exact location is Tanjung Bidara. It is about 25 kilometers from the capital states of Malacca to here, and about 150 kilometers from Kuala Lumpur. It is a southern part of Malaysia. And the latitude is 2 degrees, 17 minutes, 39 seconds north, and longitude is 102, 5 minutes, 6 seconds east. So that means it is very close to the equator. So the center is facing to the Straits of Malacca, and you can see there are lots of big ships and tankers crossing the strait every day. So ladies and gentlemen, Al-Khwarizmi Astronomy Center was built in the year 2002 by the Malacca State's government. The administration and management of this complex was placed under the Malacca State Mufti Department. The Mufti Department has an astronomy division that governs matters relating to astronomy. So this is the view of the whole astronomy center. So what we have here, on your right, you can see here, this is the first observatory we have, this manual observatory, and the far left is the robotic observatory. Also, we have a planetarium al-Khwarizmi in the between, and also we have accommodation that can accommodate about 180 people in one time, and also we have the training center. And I will explain all these facilities later. Ladies and gentlemen, the purposes of Al-Khwarizmi Astronomy Center, the first as an official site to observe crescents or hilal to determine the beginning of the Islamic months. And the second one is as an astronomy education center for school and public. And this morning, I will focus on the second function. Among the objectives are to promote awareness in the society about the importance of astronomy, to support learning activities in schools and colleges, and to support efforts in the development of knowledge in astronomy. Now I will explain the facility that we have in the centers. The first facilities is observatory. There are two major observatories that have been built here. The first observatory can be controlled manually, while the latter can be controlled remotely. This is the first observatory have been built in the year 2002 in the phase 1. For your information, the whole complex was built in 3 phases. Yes? So this is the first phase, was built in year 2002. And the first observatory is equipped with 5-meter dome that was built locally by Malaysian people here. This is the main telescope that we have in this first observatory. Okay. The main telescope is a Ritchie Chrétien with 16 inches diameter with focal ratio 8.4 carbon tube telescope. It was made by RC Optical System. And the secondary telescope that is attached to the main telescope, the secondary telescope is a Takahashi 5 inches, a refractor telescope. Its focal length is 1040 millimeter with focal ratio 8.1. And the third telescope is a finder scope that is a Bock 70 millimeter, a refractor telescope. And the mount that we use is a robotic Paramount ME with German equatorial. It was made by the BIS Incorporation. This mount has high accuracy in pointing and low periodic error. This mount can carry loads up to 68 kilograms. And the CCD camera for this system is equipped with a main CCD camera for photography and imaging research. The main camera is ST10XME built by the Santa Barbara Instruments Group, SBIG, and is attached to the main telescope. This camera is self-guiding camera. And this camera contains 2 CCD, imaging and guiding CCD. The imaging CCD is enhanced imaging detector from Kodak. This is a 3.2 megapixel CCD. Has a full frame resolution of 2184 times 1472 pixels at a 6.8 micron, while the guiding CCD is the TC237H with 657 times 495 pixels. And we also have a CCD camera. There are SBIG ST7 and Starlight Express HV9. Also, we have a video camera that is Astrovit. And the second facilities is the robotic observatory. This is a robotic telescope system which is integrated with all the system components. The system component consists of a dome, telescope, CCD cameras, weather station, video monitoring, computer and software, and automation controller. The weather monitoring station feeds many meteorological data to the main controller to alert the observatory control and active observer from any dangerous climate condition. The video monitoring system gives a continuous visual view of the observatory condition, all sky view, telescope, and dome movement and object observed. The video view can be accessed via internet all over the world. The automation controller enables this observatory being controlled remotely. So this is the observatory view. So the second observatory is equipped with a 7.4 meter dome. It was built by Ash Dome, and it is a metal hemisphere dome. And the upper and lower style shutter system allows the astronomer to view any position of the sky through a protected viewing aperture. This kind of shutter also keeps wind turbulence in the observatory to a minimum during observation operation. This is inside view of the observatory. So what we have here, the main telescope is the second. In this second observatory is also a Ritchie-Chrétien telescope. The telescope primary diameter is 24 inches, and the second mirror is 9 inches in diameter. The focal ratio is 8.0, and the focal length is 4880 millimeter. It was also built by RC Optical System. Where the second telescope is Takahashi 5 inches attached to the main telescope. The main telescope is installed with RCOS series Altazimuth fork mounts. And the telescope system is equipped with a main CCD camera, STL 11000 by SBIG. This camera is a 35 millimeter format CCD with 11 million pixels. This camera gives a wide field CCD with the same coverage as 35 millimeter film, and this is a new revolution in astrophotography. This camera is cool, linear, safeguarding, 16 bits, and optimized for high sensitivity and low noise performance in low light astronomical applications. The observer can remotely control the telescope and CCD camera via internet. So if you come to this website, you can come in and to this page, and you can see here there is 5 cameras in this page, and you can choose any 5 for this camera. Let's say you choose in the center is for the inside dome camera, so you can come into the observatory, so you can look what I'm doing there or the observer doing at the real time. And the next facility we have is Al-Khawarizmi Planetarium. For your information, this is the latest photos I taken for this before I came here. Al-Khawarizmi Planetarium is another important education facilities in this complex. This is a digital planetarium. Planetarium serves as a simulation of the phenomena of the sky, such as motion of stars, constellation, planets, the moon, and the sun. In addition, a simulation of eclipse of sun and the moon, transiting planets, comets, and others are shown. The planetarium will make teaching and learning of astronomy easier and interesting for students. This planetarium can be transformed into a classroom, seminar, and training rooms. In this planetarium, we have a 9.1 meter dome and 96, and we have a digital sky dome projector. This sky dome projector was designed to be a digital planetarium, including real-time 3D sky simulation, full dome shows, and multimedia presentations. This digital planetarium is equipped with a fisheye projector and 3-dimensional viewing system, 3D. The video with 3D effects and audio surround system make the planetarium more interesting. This means that we have 2 kinds of show. The first show is a planetarium show, and the second show is the 3D show. But if you want to see the 3D show, you should wear the special glass for 3D. For the planetarium show, currently we have Oasis in Space, Hubble Vision, Sky Quest, Dark Star Adventure, and Astronaut. And the latest, we have a black hole. This is just arrived last week, but not shown yet to the public. And for the 3D show, currently only one 3D show that we have, that is SOS Planet, a documentary film about environmental issues. Now I will explain the exhibition gallery. This is also the facility we have in the center. The gallery is to help visitors to find information about astronomy. Basic information is provided in the form of astronomical instrument, astronomical models, posters, and brochures. Traditional instruments such as Islamic astrolabe and sundial are being displayed too. But the most interesting exhibit is meteorite. This is also some of our exhibits. And a number of interactive science games are also available for visitors and interesting for the students. And this is some our interactive game. And this is a machine that we can measure our weight in any planet in our solar system. If you feel you are very weight, is heavy in this earth, so you can choose any planet here. Maybe your weight become less. The planetarium and gallery open on Tuesday to Sunday from 10 a.m. to 4:30 p.m. and close on Monday and public holiday. And the next facilities we have is training center. The training center in the complex was completed in the year 2008. It consists of training facilities like the 350 seats auditorium, multipurpose hall, and optical laboratory, computer labs, classroom, prayer rooms, and open area for night sky and hilal observations. Okay, thank you. We have three types of accommodation. We have a room type, dome type, and apartment type, and you are all welcome to this center. We also have auditorium and computer labs. This is among the visitors from overseas that have come to the center. Maybe you know this person here, I think. And also Mr. Nazar Salam from UAE. And this is from Africa and Middle East. And this is our friend from Iranian. Now I go to the education activities that are carried out here. This is among our activities, short courses, workshops, seminar, observation, astronomy club, astronomy day, exhibition, website, and competitions. For your information, at this center, there is no registered student like in school. What we have is the education activities are based on modules, and the modules offered to the secondary schools, and the school will choose which module they want. And each module takes about 1 to 3 days. This is among the modules we have, and the lectures. These are among the activities on the modules. We give lectures. This is telescope courses for public, and this is a telescope course for the schools. Also, we conduct workshop. The astronomy workshop conducted provided guidance and built the basic skills to students how to make projects, models, and experiment. The duration of the workshop is 1 to 3 days with a total of 30 of students. Among the workshop that have been carried out are how to build a sundial, telescope, and star chart. This is among the workshop that carried out. This is a quadrant. Maybe you know, in Arabic it's called Rubu' Mujayab. It can use as a clock and to tell us the prayer time, zodiac, direction of Qibla, and trigonometry problems. This is among the workshop was carried out for the student schools. They build their own quadrant and use it to measure the altitude of the sun and to solve the trigonometry problem. Also, we conduct a seminar and night sky observations. This is a night sky observation for the schools, and also astronomy club. To encourage the development of astronomy in schools, schools are encouraged to form astronomy club. Guide is provided to help teachers and students to conduct astronomy activities in school. The guide contains theories and practice of proposed activities. Among of the activities are solar observation, build a star chart, and build a sundial. These are among the activities: is solar observation, school and teachers, teachers and students. These activities on star chart.
دقيقة واحدة. 1 minute.
Okay. This is an example of a school astronomy club. They have their own telescope and project and so on. And also exhibitions we are also carried out. And the most interesting activity is Astronomy Day. This is, we have done it last 2 weeks, I think. This is among the activity on the Astronomy Day. Okay. We have astronomy talk, robotic competitions, and so on. Also water bottle rocket competitions, and also we conduct a competition online astronomy quiz for secondary school, online astronomy quiz, open to public website building competition on astronomy. This is the online astronomy quiz. So the student set for the astronomy quiz via internet. Also we conduct website building competition. This is one example. The website was built by the school's student, and the winner of the competition we receive a telescope. And earlier also I have mentioned that the center as an official site to do moon sighting for determining the beginning of the Islamic months. So every month we will do moon sighting, and this is among the hilal was seen in the center. We use a telescope or binocular or theodolite. This is among research was carried out as ACD imaging. Also, we have astronomy on air in the local radio station. So for those who are interested, they can hear through the local radio station, or they can download the audio and the text from the website. For ladies and gentlemen, for further information, you can go to this website to get more information. And one interesting in this page is there is windows here. There is live for moon sighting or live from the observatory. Thank you very much.